Hey, hi all. Good evening and welcome to this Solve with Instructor session for week 10. I'm audible, right?
Yes, you are.
Yeah, okay. So today we are going to cover mathematical aspects of GradBoost, AdaBoost and XGBoost with some examples in Solve with Instructor session, and then we can be open to doubts if any. So I
Yeah,
think coding part we have seen in the videos, right? So I thought it's a good idea to have mathematical aspect of it. So
correct.
yeah, so one by one we will cover each of the techniques. Boost these techniques. These are predominantly boosting techniques only. Okay, so anything that you want to share with me at the beginning? Any feedback and review?
Yeah, a lot of confusions around this backing and boosting.
So if I mean let people join till then. If you have any doubt, we can solve it.
Yeah, did you I have posted couple of questions in regarding backing and boosting, like in the Discord forum. Did you get a chance to look at them?
Yeah, I'm really sorry. I could not see it. So you want me to answer there or
No, but if you can take some of them at least. Okay.
okay? So I'll try. So you can go ahead with shooting your questions.
Okay. Say for example, whenever we are using this bagging or boosting, okay, in the how it is exactly working in the sense mathematically how can we convince ourselves that bagging is reducing the variance.
Okay. So take for instance, suppose you take one model, right? So in one model we have a given data set and we are training a model on it. So so the chances of overfitting is more because there is one model, right? But suppose we take different bags from a given model. Okay, so let me explain through an example. Suppose we have 1 to 100 data having features x1, x2, so and so, and we have a target variable y. So let me call 2, 3, whatever, 4, and 5, 6, 9, then 1, 1, and 13. Okay. Now, what happens in general? We build one model from this data set, right? From this data
Hmm.
set, we are building a model directly. Now, there is a chance that it will overfit. If we have, so can you tell me when overfitting happens?
Yeah,
So what?
whenever it will try to memorize the training data.
Yeah, it is going to memorize the training data. It means training loss is low,
Low, the test is high.
test loss is high, right? Now, what happens in case of bagging or boosting, mainly ensemble learning? What happens? We are going to divide. So let me first cover bagging. So in bagging, what will happen? This whole entire data set, 1 to 100, will be converted to bags, let's say of size 60. So of 60. So here, one thing that you should keep in mind, and suppose we have 10 such bags. Okay, so what happens? We are taking from for each bag. Suppose we have bag one, it will have 60 elements. Bag two will have 60 elements, and so and so, right? So
Hmm.
these elements are taken with replacement. So in every bag there can be some data sets which are repeated, these records which are repeated. Okay,
Hmm.
so what
Hmm.
will happen? Now there will be a model from bag one, there will be a model from bag two, and similarly there will be a model from bag three. Now suppose we have 10 bags, okay, and we have 10 models. So out of these 10 models, it can happen that some models overfit and some models underfit, right? So when we take a combined effect of that, what will happen? This overfitting will reduce.
Yeah, that is predominantly because you are voting and with an assumption that.
So the very idea.
Go ahead.
Yeah, hello.
Hello.
Hello, am I audible?
Yes, you are audible now.
Yeah, so this is what happens, right? So if there are 10 models, so we can very well assume that there will be models which will underfit and overfit, right? So in that sense, we are going to reduce the variance.
Yeah, but this is with couple of assumptions. Like point number one is like you are mainly your thing is like your prediction is based on the voting. Okay. Now say for
Yes.
example all these 10 models. Okay. If they are not they are weak learners. Okay.
Okay, so tell me one thing. I want to ask you a question. So out of the 10 models, won't be there any model which will underfit?
Yes. So now like there are possibilities that some models are good, some models are bad. But
Yeah.
the reason we are doing this bagging and boostings is predominantly we are taking weak learners and making a composition and finding out something some good classifiers out of
Yeah,
that,
that's
right?
yeah,
So
correct.
the base understanding is these all these models are weak learners. They are little better than random classifier.
Yeah,
No,
so we are basically saying community is better than individual.
Right.
no, but one sec. Just sorry, Rajiv, Srinivasan here. For boosting,
Yeah.
definitely we assume that the model is weak. We are improving it. And bagging, are we doing that? Are we assuming that each model is weak by itself? I
No,
don't think
no.
we are doing that.
So there can be weak and strong learners both. So, but we are finally taking a vote out of it, right?
Yes.
Yeah. So
So,
that way there is a
so
difference between bagging and boosting, right? We
yeah. So
don't.
this is the basic idea. Community is better than individual. So every time we think of an individual, there can be many wrong things, right? But community as a whole nullifies that. So that is what happens in case of
Correct. So
ensemble learning.
now, say for example, for model if you are taking individuals, say for example M1, M2, M3, like if you take the individual, okay, and assume their the error they produce is kind of a epsilon, okay,
Okay.
and which is a maybe follows a standard normal, okay.
Okay. Okay.
Now my point here is like if you increase these models, say for example now you have 10 models, okay, you
Hmm.
get a variance, okay,
Okay.
variance of that epsilon. If I make
Okay.
it 100, the variance
Yeah.
will further reduce,
Yeah. It should.
and if I make 1000, it will be close to zero.
Yeah. So yeah.
Is it something like is there a limit?
So see, you cannot produce a perfect model. Anyways, I mean, even if you try to produce, it won't happen. But yes, variance should go on reducing, and the model should become more accurate as we
Yeah,
go on increasing the number of models.
intuitively that part is okay. Intuitively that part is okay because you are taking a voting, right? That is the reason you are saying, okay, in my prediction, whether it
Hmm.
is good or bad, in my prediction, I am reducing the variance.
Yeah.
Okay, now the point is like,
See, Rajiv, what you are talking about is true if we consider that most of your models are wrong. Then what will happen that variance will not reduce. So we have already talked about this in last session. I think some girl, Shreya, I think. So I told that we assume that error rate is greater than 50%. So if we assume that our model itself, all the models are bad, then our combined effect will be bad only.
So that means like so bagging will like it will not improve the performance, right? It will only improve in reducing the variance. Is that a legitimate statement then?
No, it will improve the performance. So for instance, there are 6 models. So if you are creating individual models, one model can be very good, one model can be very bad, right? But if you are taking a combined effect, what will happen? The limitations of each model get cancelled out. And predominantly we are left with good things. This is what happens.
See this, Srinivasan here, this cancelling out, I'm not sure whether it is definitely something we can state. That day I was, I was outside, so I couldn't get to that discussion. The reason is that, so there are, in theory, I mean, in practice, we know that, you take a selection of bad things and then you put a thing around it, does not necessarily become good. I think that's probably where Rajiv's question is coming.
Right,
Yeah.
absolutely.
So you are correct. We are taking certain assumptions into whenever modeling. So I am not denying that fact.
So that means like it is like a fair statement that okay, if you are using a bagging, you don't care like how good the final output will be. You only care that okay, whatever I have, I will reduce the variance. That's all.
So
That
see,
part you can
therefore,
comfortably say.
yeah. So what we exactly do, I mean, we have different kind of techniques. So for instance, in case of bagging, when you are taking random forest, what exactly you are doing? You are taking different trees, right, with some features and some rows. So at last, what happens? We are taking different combinations and we take the best combinations out of those, right?
See, that's what I am telling you. Say for example, you have 10 models, right? M1 is very good. Okay, M1 is very good. It has like 95% accuracy. Okay, and the remaining like all these guys like say for example 50% are very good, 95% accuracy, and remaining are not good. Okay, so these irrespective like instead of doing bagging, I will take those five classifier, right? And I will say okay, like I will use these five classifiers instead of going for a bagging.
So
But
see, that's completely your discretion. So when we are learning ensemble learning, what we do, we take the effect of all. So, but as a data scientist, that discretion you have to do. I mean, if you can build a model based on data which is better than an ensemble, you'll go with that. There is
see
no
the
doubt in that.
thing why I am asking these questions like
No, you are
to
right. I mean, I agree with this completely.
make
So
that
see,
thing understanding like in which circumstances I will go for a bagging and not.
so it depends on how your model is performing. So if you are saying a ensemble is not performing better than a given model, you will go with that model, right? Why to go for ensemble then?
I have a question here. Is it possible that if we have 10 models, 5 are very good and 5 are very bad? Because the whole idea of bootstrapping is to generalize models. So how can you generalize 5 which are, then that means that your test set is not right. That means it's predicting very good on test set and it's biased towards the test.
So what happens during bagging? I mean, this bootstrapping. One thing that you should keep in mind: we take more than 2/3 of the data in a bag. This is I mean, thumb rule. So if you have 100 data set, I mean points, 100 records, then you will take 2/3 into 100 plus some n. Okay, so it cannot be less than that. So basically, when you are taking this kind of 2/3 majority, so what happens? Your model, whichever model you are forming, M1, M2, M3, whatever, it will be very close to a model which will be produced if you take the whole 100 data sets. It's not like that you are dividing 100 into pieces of 10, 10, 10.
Yeah, that part I understood, but this 2/3 part is something I didn't know. Okay.
So now see, when you are taking this, so this is what happens practically. You take 2/3 into the number of records plus some n, which makes it greater than 2/3. So you basically take you build a model on more than 2/3 majority of the data.
Okay.
That is okay. Now the point here is like extending to Shreya's point, right? You took some samples, okay, like that 2/3 or some like whatever that heuristics, okay. You took that
Okay.
sample. Now the classifiers that is used inside this bagging, right?
Okay.
Whether those classifiers are like kind of a weak learners, like little better than random classifier. Say for example, with 51% it can say okay good, and like +1 and 49% -1. Okay, is it little better than just a random classifier? That
So,
way,
yeah.
no. See.
Go ahead.
First, understand like why I'm asking this question.
Yeah.
My
Okay, go ahead.
entire point is bagging anyway improving the like classification model?
In bagging, we are improving the overall prediction, not the individual classifiers. Hello?
Yeah, probably like either my network connection is bad or yours is bad. Like I'm not able to hear you properly.
So, am I audible now?
Yes.
So, I was saying bagging improves the overall prediction, not individual models.
Not individual model, but overall prediction, and that is just because like you are taking the average of it.
Yeah, correct.
Majority voting.
You are right. Yeah, you are right.
Okay, so that way, like we can say if majority tells 1, then it will say 1. So that means it is reducing the variance. That's all. It is not improving the models
correct.
at all.
So,
Perfect.
so basically, when you are taking 2/3 data, how can you say the model will be better than the overall data model?
No. Say for example, you have 1 million record, and in that you are taking like your 70% data. That is good enough. Good enough for training.
Not necessarily. If you are ignoring 30% data, how can you say it's good enough?
Anyway,
so
like
you are
we
taking
generally keep
70%,
20%.
ignoring 30%.
Yeah, generally like we keep 20% as this kind of thing, right? Test size.
Okay, so see here the 70% is out of training data.
But
now,
anyway,
are you getting
those
me?
no, like I am not pretty convinced on that data part, because data is okay. Like say for example, if you have less data, you will get bad thing. That is perfectly all right. But say for example, you have 1 million record, and out of that 70% data you are giving to this, and like from there you are doing a random sample with replacement. So assume that data is not a crunch. Like let us not
We cannot
introduce that
assume
fact.
that thing in data science, right? Data is something on which the whole analysis depends.
Right. Like the problem is like if you have 1 million record and you are supposed to train a classifier on that, then you have to live with that constraint. So
Yeah,
we cannot like do anything on that. Okay.
Yeah, correct.
Now you have taken those data with replacement. This bagging is not improving the performance of these classifiers. It is only reducing the variance.
Yeah, correct. It is going to give me overall prediction which is close to reality. It is not going to improve individual classifiers for sure.
No, but when you say like a
Rajiv,
close to reality, there I have a question actually.
No, Rajiv, can I give a different,
go
very
ahead,
different thing?
Srinivasan sir.
Yeah, maybe Shreya can also add. See, so because this is what I have to tell my clients, right? So if we have more than one investment, this is what we call a portfolio, right? So some investments may do better, some investments may not do well, right? By having more investments, we cannot go better than the best investment. Okay, there is just no way, right? What we can do is, but see, suppose I had only one, I could make only one, right? I choose a very bad investment, right? Then it'll give me very bad returns, right? And I may be lucky, I may choose the best instrument and may give you very good returns. But usually I don't know whether I'm going to be lucky or unlucky. So if I have more, what happens is I get a weighted average of this. That way, if 5 different people do this, right, their weighted averages will be quite close because none of us is relying on our luck or our skill. right? So that is how I would put it that way, right? So
yeah, it's like diversification, right?
Yeah.
Srinivasan sir.
The final output is not going to be better than the best model. It will always be worse than the best model, but it is very likely going to be better than the worst model also.
Yeah, it's like taking an average.
What I want to ask here is like how improving performance is related to reducing variance, right? You may improve performance on one test set. That does not mean that your model is doing well. Is that your question?
No, say for example, you have 10 classifier, all are biased classifier, okay?
Okay.
All are biased classifier and all gives like always predict one.
That's the thing. Because of the way
Okay.
samples are picked in Bootstrap, you can't have biased classifiers. The sum of all their performance will give you an average, like Srinivasan sir pointed out, will give you an average which will give a reasonably good prediction because of Bootstrap sampling.
Yeah, like your Bootstrap sampling, like okay, that is okay. Now the point here is like if you have all these, like see that point, I agree that okay, it cannot give you the better performance than the best classifier. That I can accept. Okay, but the point here is like it will not improve the performance of a classifier. It will just reduce the variance.
So reducing variance.
Yeah, what I
Reducing
wanted
variance
to
is
say
not the
was
improving performance.
performance of your classifier is relative to test sets, right? Like it may, like it depends on what is the score it is giving on your test set. If one model is giving you, let's say you have 10 test sets, and if one model is giving you best score on 3 but then is giving you bad scores on the other 7, but then the other model is giving you average on all the 10 test sets, which one would you prefer? Bagging will give you the second kind of classifier.
No, come again.
If you have 10 test sets, you have a classifier which will give you very good predictions on 3. But bad predictions on the other 7. The performance of that model is not something that you'd be okay with, right? Because the performance is relative to test sets. It's not performance like you. How would you call it a best classifier? It depends on the test sets, right? In the second case, if you have 10 test sets and it is giving average predictions across all the 10, you will still prefer the second one, right?
Correct, but see, now think this way. Okay, you have 10 classifiers. Okay, now at the time of predictions, you have been given a one set of data. Correct?
Okay.
Your classifier 1 predicts something, classifier 2 predicts something like that, and you add that up. You say, okay, this is my majority, so I will tell this. Correct?
Yeah.
You are introduced to like a same test data to all the classifiers.
Okay.
Now, like you won't get a better performance than the best classifier, right?
That's what I'm saying. You are talking about performance on one test set, but that model may be very bad on the other 9 test sets. So it may be a bad model overall, but you're saying it is great performance on one test set. Based on that, you can't conclude, right?
Okay, you are okay, understood.
And
So
Rajiv, yes, reducing variance is a measure of performance. Why you are saying it is not?
Reducing variance actually, like in my mind, like you are like error variance.
If okay, let me give you an instance. I have two models, one with very high variance and another with relatively less variance. Which model you will prefer?
Less variance.
So is it not a measure of performance? Why
No,
will you
like
choose a model with less variance?
but like it will not improve your prediction capacity, right?
So why not? See what happens in case if variance is more, it means model is overfitting. It means it will not perform good on test set. But if variance is low, it means model is not overfitting. It means it has a higher chance of predicting well in test set. So its performance is improved.
But the performance, like if you see those
So
all these
what
codes,
exactly
right?
is the meaning of performance according to you?
Absolutely, like I was about to ask you. Now, whatever score we have been calculating so far, right? On that mean square error or like your F1 score or F2 score.
Yeah.
Can we improve on any of these code using this bagging?
Yeah, for sure. So if your variance is reducing, it means your data is going, so your model is going to perform well on test set, right? So performing well means we are saying performing well. Performing well. It means performance is improving.
Sir, I actually have a point here. So if we have a test set which is very similar to the training set, then it may actually reduce the performance. But
So we
over
take test set randomly, right?
correct, over a bunch of test sets or a randomly chosen test set, it is likely to improve the predictions.
Yeah, for sure. Yeah, so that's what I also mean. Anything, Rajiv, other doubts? I mean, if you are okay with this, I mean, you are not satisfied. That what I can feel.
What is that?
So for this particular question, are you satisfied with all the discussion?
No, like at least like this thing, like whatever I heard at the end, like over a bunch of different test sets. So probably like that is making sense. But again, like the thing that I'm like not able to convince myself is like not able to convince is like we can make a better thing with using weak classifiers.
Okay, so weak classifier comes in case of boosting. Here in
Okay,
bagging, yeah,
like
you
weak
can say weak,
classifiers is not the case for
but
bagging.
no, it's like individual models are created. There is nothing called
Hmm.
weak in case of bagging.
Hmm.
So in boosting,
Okay.
what happens? We go from 1 week, make it stronger, then make it stronger, and we go on making stronger till the boost rounds complete.
Okay.
Yeah. Okay. So any other question?
And say for example, if we increase the number of classifier to very high, so we can make variance 0, right?
No, not exactly 0, but very close to some very
Very
small
close
number.
to 0.
Yeah. Correct. You are right on that part.
So it is inversely proportional to the number of classifiers.
Yeah, correct. But it's like one thing that I want to tell you. So suppose this also happens practically. Suppose you are dealing in a situation where you are dividing your model into suppose 10 bags. Now you get a particular variance. Then you divide into 20. You get some other variance. 30, some variance which is less than 20. So what happens after a level it saturates. So suppose that number is 35. So after 35, if you go on making it 45, it will not reduce further. There will be very small change. So that is again something which we have to take care of. So what is that optimal number of bags? That is a kind of hyperparameter tuning that we do.
Okay, are these classifiers some way correlated or they are like kind of IIDs?
They are IIDs, kind of
They are
IIDs.
IIDs, right?
Yeah.
Okay, so that means your expected value of these
So
okay
it's like
variance.
in KNN there is a elbow value, right?
No, because like since we are using a random sample of that
No.
training data, right?
I want to convey something else. So in KNN, what happens? There is a value of K which is optimal, right? So similarly here there is a number of classifiers which is optimal. If you go beyond that, there is no much improvement in performance.
Yeah, if it becomes almost 0, then of course there will be not much.
Yeah.
Okay.
Okay. So shall we move to the question parts now?
Yes, we can.
Yeah.
And
Okay.
then probably like again at the end, like we might come back. We would like to like probably if you can come back and talk something about that boosting as well.
Yeah, sure. So actually, these kind of discussions are what makes the live sessions live, right? Okay. So first thing, let's talk about GradBoost, the mathematical aspects of it. So coding part, I think you must have seen from the video. So let me give you a situation. Suppose there is a company X which produces some product whose cost is given in the third column, and the advertising cost is given in the second column. And suppose the profit made is 8, 10, and 12, all in million INR. Okay, all these numbers are there. Now, suppose I want to build a model on this, a regression model, and make some kind of prediction. So what happens in case of GradBoost, how we go about it? So if you have seen the video, I think the steps are with you. So anyone who can tell me what exactly, or you want to do it on your own, if mathematical part is clear.
Yeah. So first, like your like profit is the like y, right? Your
Yeah,
predicted.
target variable. Yeah.
Yeah. So y mean is 12 plus 10, 22, 30, 10.
Okay. So see, yeah. So first step that we do in case of gradient boosting is we make a base model. Okay. Step one is making a base model. Okay. So shall I? Okay, let me share my screen and see these steps. So this is visible to all of you, right?
Yes. Yes.
Yeah. So the first step is make a first guess. So I am saying it's like a making a base model. So what exactly we do? We take the average of the given y's. Okay. So in our case, our y's are these profit. So the first step will be taking the average of it.
Correct. So that means
Yeah.
it will be predicting 10.
Yeah. So step one will be y hat equal to y1 plus y2 plus y3 by 3. Okay. So it will be like 8 plus 10 plus 12 by 3, which will give me 10, right?
Hmm.
So this is my first step. We are taking y hat equal to 10. Okay. Next step, what we do next?
Residuals.
Yeah, we find residuals. So step 2 will be finding residuals. So how we find residual? It is y minus y hat, or y individuals, yi is minus y hat. So
Right.
here, suppose I add a column.
Minus 22.
So here it will be residuals, not minus 22. How come minus
Minus
22?
2, minus 2, 0 and 2.
10,
Minus
10. I was in 30.
Yeah. 10 minus 10 is
0.
0 and 12 minus 10 is 2. Okay. So this is what happens in step 2. So up to step 1 and step 2 is clear with everyone, right? So if you have pen, paper, or you may use anything, talk and all, and solve with me. Okay. So this is what happens for the second step. We find the residuals. So what happens in step 3 in case of grade boost? So let's see. Step 3 is fit a weak learner to residuals, minimizing the loss function. Let's call it F naught. So this F naught is what? Any idea?
F naught is the classifier, that function.
So what kind of function?
Like any function actually, like it can be logistic regression also.
Okay, logistic regression. So okay, I get you. So F naught. Any other answer?
F naught is just put the mean, right? So basically that would be equal to mean, right? That's all.
No.
We can
Actually,
use decision
Srinivasan,
trees
yeah,
also, right?
What?
We can use decision trees also, right?
Yeah, so F naught is basically a model that you are using.
Yes.
So F naught can be logistic regression, as Rajiv said, or decision tree, as Shreya said, or it can be a regression, whatever you want to use. So basically, F naught is the learner model that you want to use. So here in our case, what learner model we should use?
No, that's why. Can it be a dummy regressor with strategy equal to mean?
No, that is the first
Yeah,
one,
so
right?
see, yeah, so mean you have already taken in step 1.
That's the bootstrap. So can't F naught be the same? No.
No, so F naught is basically the strategy that you are taking to model this out. So for instance, here I think linear regression will be a model that we can go about, right? Or we can use decision tree, whatever suits us. It completely depends on us which model we want to choose, or we can choose more than 2, 3, and then select the best out of those.
Srinivasan,
So let's,
there's no bootstrap here.
yeah, it is boosting.
It's just base. No, there's just a baseline model, right? Like, or
Yes. See, bootstrap is when you are choosing multiple samples from the training set. That np.random.choice, that line of code, that is bootstrapping. Like you are creating like a m data set, d1, d2, dm, that is called bootstrap.
Yeah, okay. So here, suppose we choose linear regression as our model.
Linear regression, yes.
Because we already are familiar with linear regression, let's choose this. So what happens in step 3, which is very important that you should keep in mind. Now what we exactly do, we make,
Like say for example
residual
15w.
as target. I mean, if you have seen that collab, so here that is written more formally, but informally what exactly we do, we make residual as target.
Correct. So that
And
means
then,
15w1 plus 49w2 equal to 2 minus 2.
yeah,
That kind of
correct,
equation.
correct. So that kind of equation, we basically make the residuals as target, and then what we do, we fit the model. So can you do that? Because regression you already know.
So that is like kind of a normal equation, right? We can create a normal equation and solve it.
Yeah, in this case, it is like a normal equation. So
Yes.
basically, if there are a lot of, so if you take a lot of data, the whole uh, this exercise of explaining will be over then and there. So basically, what we know, we have to do this: A transpose AX equal to A transpose Y. Correct. If we have a lot of data, we have to do this. But since we have only these 3, we can solve this simultaneously. Correct.
Okay. Yeah.
So can you do this?
Yeah,
Give me a
15,
model.
49, 21, 21, 61, right?
Okay, I think you have to do this A transpose A X equal to A
I'll do
transpose
that
Y.
only. I just opened a collab actually.
Yeah. So why? Can you tell me the reason why I'm saying we have to go with this and not normal equation?
Which one?
So you said
Like with that you will get w equal to like residual 0. If we are using this new like normal equation, right, we'll get the residual 0.
yeah. So see, basically, if you see the number of variables and the number of equations that we have how many equations? 3. And how many variables? 2.
Yeah, 2.
So this is the reason we have to go for projections, not directly. So I think MLF is coming into use here, which all of you thought MLF will never be used.
Sorry, I got a bit lost. What is the problem that we are trying to solve? Sorry, can you just mention that?
Yeah, so I was saying that why we cannot use directly solving these three equations to get weights. Why we need to use this A transpose AX equal to A transpose Y. This is because the number of variables that we
may not
want.
be inversible, right? So the may not be able to inverse it also.
Yeah,
right?
so the number of variables is less than the number of equations. Okay.
Yeah,
that's the reason.
Yeah, so you need a pseudo inverse, which is basically, I mean, of course, we can't calculate pseudo inverse by hand.
So therefore, we go for projections.
No, but X transpose is always invertible.
A transpose A is always invertible. Yeah. So what is the model that you are getting? You have opened a collab, right?
Yeah, opened a collab.
So is there anyone who is solving?
No, that's why I'm sorry. So what is that? Are we trying to calculate x r here, the x here?
Yeah. So sir, basically what we are doing, we are taking residuals which we got here as target variables, and these two, advertising and product, will be our features, and then express residuals in terms of these two features.
Got that? Okay, fine.
Like 1.44 into 10 to the power minus 2. Another is very small, minus 8.6 into 10 to the power minus 16.
Okay, so this is, I'm assuming this is correct. Okay, let us call it advertising and let us call it product cost. Okay. So this is what we are getting as residual. Now what we need to do, the next step, then comes step 4. Now we have to calculate our predictions using this equation. So these are the real residuals, right? The actual residuals that we got. Now we have to calculate another column, predicted residuals, based on this particular equation. Are you getting me?
Correct.
So what those values are, can you find out? So I am assuming this model is correct. So if anyone else can confirm this, because I have not solved it.
Yeah, it's correct.
Okay.
So with this, the residuals will be 0 actually.
So what you are getting?
With this, the residuals will be 0.
Not 0. So you should get a value here, right?
No. The thing is that, like, I use that normal equation, right?
Yeah.
So normal equation is like x inverse w, right? P inverse, like P inv, pseudo inverse. Okay, so that means what? You are getting a very good solution of w, right? Then it will make 0.
So I'm not exactly getting you what you are saying.
Okay, say for example, now you have this x1, x2. Okay, 15, 49, those things, x1, x2. Okay.
Okay.
And your y is 2, minus 2, 0, 2. Okay. Now if I solve this using normal equation, I get a very close w which will make the residual 0, right?
No. Sorry, Rajiv, you have to get the actual y, not get the difference.
No. Like you'll have to use the residuals. That's why we calculated in that first column residuals, right?
No, minus 202 itself is a residual.
Correct. So your x1, x2 is the input, w1, w2 is the like variable, and your target is y. Y is now minus 2, 0, 2.
Yes,
that is
correct.
That is step 3, right? And there I calculated.
Yeah, that is step 3.
Yeah, those w's. Now in step 3 it is converging. That means you get
so
almost.
In step 3, what you need to do, you have to use these w's which you got, 1.44 into 10 raised to minus 2 and 8.6 into 10 raised to minus 8. and calculate your residues, what you are getting
Yes.
here.
So I can calculate that, but it will be very close to 0. Let me calculate.
So it will not be very close to 0. It will be very close to -2.
This number, that's why I'm saying, Ajay, will be close to -2, 0, and 2. So it'll be very, very close. I think -1.9, -1.9.
So any so
No,
you just put
then
it,
the residuals. Now the residuals will be -2 minus whatever value I am getting, right?
Yeah, so residual will reduce, that's for sure.
Yeah, residuals will close to 0, right?
So as we go on increasing the steps, iterations, residuals will finally come to 0, but not necessarily in the first step.
No, but
Yeah,
here, because we are using normal equation,
it will be 0. Like I'll calculate.
If it was gradient descent, we go by that learning
Right,
rate.
right.
So it will go on reducing. But here, since we're directly equating to 0, the step 2 itself will make the residual 0.
W transpose.
Wait. Sorry.
X
What is residual? Here,
minus.
the residual here is the actual thing that we are trying to predict. Okay. So the error between the actual residual and the predicted residuals may be close to 0. The residuals itself will be close to -2, 0, and 2. Am I?
So see, I am getting -0.432. I am not getting 0. I am getting -0.432.
Yeah, like
So I may be wrong. I have put it in calculator and find out.
no,
So you may
but
check.
yeah, I think what Srinivasan says was correct here. Like it is giving -2.2173, like the first one. Then the second one is -0.304, and the third one is 1.65.
Okay, so this -0.432 is wrong.
Sorry? Yeah. That will be -2.217.
Okay. Minus.
2.217.
Okay, so it should not happen. I think it should reduce in absolute values.
Yeah, see what I did. Now I got this W, right? I told you the W's. What I did, Y minus XW.
Y minus XW means you are doing. Why you are doing Y minus XW?
That will be the residuals, right? Y is -2.
No, you okay. So no, you have to just find R.
XW first.
Okay.
R by putting A and P. See what you have done. You so here in step 3 you have calculated R equal to W0 A plus W1 P. Correct?
Correct.
Okay. Now what happens? Now you have to find R predicted. What you will do? You will now put the values of W0 and real A. A is how much? 15 plus W1, which is you calculated into 49.
Yeah, so this R value will be 0.217.
0.217.
This W transpose X, right? If I calculate that, it is W transpose X.
Okay, let me put it. So 1.44 into 10 raised to -2 that you got, right? For advertising. Multiplied by 15. Then the equation is -8.6 into 10 raised to -16, right?
Correct.
And multiply it with P, which is 49. So you are getting 0.216.
Right, 0.217. Then the second.
I am getting 0.216.
No, anyway, like that is correct.
So it's not 2 point something. It's
no, so 0 point, like 0 point. Yeah. Then 0.304. Yes.
Yeah, and
0.347.
347. So this
Yes.
is what happens in step 4. Okay, you calculate the predicted residuals. Now next step is very interesting. Now what you do in step 5, I'll provide you with all these things. It's just for solving it. You will calculate now y's. So y will be equal to now y base plus alpha into predicted residuals, where alpha is the learning rate. Generally we take 0.1. So
You are
basically
right,
what,
right.
so y will become what? Y base. What was our y base?
10 plus that.
0.1 into now our predicted residual. So what was our predicted residual? 0.216. Okay. So for first, it will become 10 plus 0.0216, which is 10.0216. So similarly for second, this is for y1. Similarly for y2, we'll get 10 plus 0.1 into 0.304. So which is equal to 10.0304. And y3 will be 10 plus 0.1 into 0.347. So which is equal to 10 plus, so 10.0347. Okay, now you have got new y's, correct? So now these new y's will replace y hat. So step 6 will be replace y hat by y new. And step 7, calculate new residuals. Are you getting me?
Yes.
So what will happen now? New residuals. So suppose for first, now I calculate residual for 1. Now it will be actual, how much was the value? 8. Okay, now it will be 8 minus whatever we got now. 8
The y new.
minus 10.016, whatever, y new. So it will give me new residual. Similarly for R2, new residual. For R3, new residual. So now what we have to do? Now we have to repeat from step
2.
Step 3 to 7.
Correct.
Yeah. So this is how we go about solving grad boost. Okay, got it. The mathematical intuition is clear, right?
Yes.
Actually, I have a doubt in.
So the programming part of it you have already seen. Any doubt in this? Any step?
Yeah, like what is the reason we are actually getting some values in residuals? Like it should. Actually, I realized that was not right. It should be close to minus 202, right? Why? How are we getting different values?
So see, what happens when you fit a linear regression model? You don't actually get the actual values, okay? Do you get it? I mean, when you are doing y equal to c0 plus u1 x1 plus u2 x2, so that value may not be the actual value, correct? So here your target values were residuals, and this column which I am marking now is the predicted residuals. So it will not be exactly equal to the actual residuals, right?
Okay, I have a further question then. If we add some sort of bias to this, then is it likely that it will be more closer to minus 202?
Yeah, so bias can come. Bias can come if your model gives a W naught which is non-zero. So in our case, luckily we had no bias.
Okay.
But that will be taken into account. I mean, when we calculate this predicted residual.
Okay. No, what I mean is, like, if I train the same thing with the bias,
So you cannot train it with bias, right? Bias is a variable. Either it will be 0 or non-zero. So in our
No,
case, it
sorry,
will
I
be
meant
0.
with the dummy feature.
Yeah, so you have to do that. So you did not do that.
No, I don't think we did that because we
So
got
you
only
have to
two
do that.
weight vectors, right?
Okay, so you have to do that.
Yeah, so I think in that case, it will be closer to -202. We'll try it out probably.
Yeah. So I thought you did that, and I thought W0 is 0. So you have to do proper linear regression then. Not like you just assume that W0 is 0. So
Correct.
see,
The W0 needs to be considered.
so y equal to, we have to fit this model. C0 x2, we have to fit this whole model. I thought C0 came out to be 0. I did not thought that you took C0 0 for while calculating. Okay, so you can do that correction, right? Or yourself, you got the this algorithm. Any doubt in the algorithm part?
No.
Yeah. So I think algorithmically it is correct. Okay. So this thing you have to keep in mind. I thought you have considered it, but you did not. So you have to fit the proper linear regression model. Okay. So can we move to XGBoost if we are clear with AdaBoost? Sorry, GradBoost.
Yeah, like if we take that one also into consideration, then the
Or any
like
doubt?
residual has changed. Like
Yeah, then it's
it has
very close
reduced.
to -202.
Right.
Obviously, it will change.
It's
Yeah, it
almost
will be
equal to
close to
-202.
-202.
Yeah.
That's what I told you in
Yeah.
the beginning.
So then further iterations will
So
not be.
finally, see, as the number of steps goes on increasing, this iteration goes on increasing. Yeah. So what will happen? This residuals will go on increasing as the number of iterations go on increasing. Yeah, correct. So can we move to XGBoost?
Yes, I will review the steps again. I think I got a lost
Am I
between
audible?
you do have some issues, so maybe some network issues. You asked whether we can go to XGBoost. Yeah, we can. I just mentioning that I got slightly lost between step 5 and 6. I will review the video and then catch up with it.
Okay. Okay. So let's first see the steps in XGBoost. Okay. So I have to stop sharing for some time. I'll. Have you received week 10 slides?
The last time I saw it was not there. Let me check again.
Yeah, so in slides, see this XGBoost will not be a part of your evaluation. I'm just covering it for your understanding because it is one of the most important or used algorithm in case of Have you all, do you all participate in Kaggle competitions?
Not yet.
Which
Yeah,
competition?
like not
Kaggle.
yet.
Yeah, so you should try once. So it will increase your proficiency in machine learning for sure.
So even for others, week 10 slides have been just uploaded as of 3:20 p.m. So
Okay, thanks a lot. So XGBoost is what we are going to cover. So basically, some introduction to it. So it is an abbreviation for extreme gradient boost. Basically, it builds upon gradient. It is a PhD scholar then in some university. So it is one of the most famous algorithms which is used nowadays. So it was not covered due to the scope of this course doesn't allow it. It is advanced thing. So basically, XGBoost has three parameters: regularization parameter, then threshold used for auto pruning, and there is another parameter eta, which is parameter used for convergence, just like learning rate. Okay, so what are the different steps involved? See, there can be two kind of XGBoost. One is XGBoost regression and XGBoost classification. So the first step one is, so what we do, we build a base model. Then we find residuals, just like gradient boost case only. From step 3, the things changes. Now in step 3, what happens? So there what we were doing, we were fitting the model on residuals, right? Now here we have a similarity score parameter, which is given by this. So if you have solved the practice programming questions, you are familiar with this formula. So this is what we do. So when we will solve the numerical, it will be clear. Okay. In step 4, we choose a splitting criteria. So this
Okay, can you
splitting
go back to
criteria,
step 3?
So node here basically means that part of the tree.
yeah, it's a part of tree.
No,
Yeah,
So it means it's for all the samples.
yeah.
Yeah, like how it is a similarity measure? Some of the residuals at the top node.
I think
Yeah,
it's
so
a
there
name.
is a very big maths behind it, which Taiki Chen has written in his paper. So I think that paper is available on web. You can check that, and it's a very interesting paper. So how he has come to this conclusion, it is there, and it has a lot of mathematical intricacies. So which is beyond the scope of our discussion for now. Yeah, it uses Taylor series to a large extent, Newton's method, which was not covered in MLF. All these things are there. Okay, so I will encourage all of you to go through that paper once.
What is lambda here is just some regularization parameter.
Yeah, so lambda is a regularization
Okay.
parameter which reduces overfitting if it is.
Hello, so you're not audible.
Okay. Yeah, I think there is some network issue on my side.
Yeah, now it's fine, I think.
Am I audible now?
Yeah,
Now it is
you're
fine.
Yeah,
Once in a
okay.
while, some sentence gets into a problem, but usually it is okay. But once in a while, we get an audio problem.
Yeah, so I think there is some bad network here. Okay, I'm sorry for that. So next step is choosing a splitting criterion, and then we split the branch. Then we calculate gain. So again, which is similarity score after split and similarity score before split. I'll cover all those things. Okay.
Oh,
You need
okay.
not
So
worry
this
about
is
it.
equivalent to the Gini index or entropy.
Yeah, so it is just like an information gain. Okay. So next thing is if gain is greater than gamma, which I'll talk, split is allowed, otherwise not. Okay. Next is new prediction, which will be based on previous prediction plus eta, which is nothing like but like a learning rate into output. Output, what is output? Output is this: sum of residual at node divided by number of residuals plus lambda. And then we repeat the steps 3 to 7. So I'll cover all these things in our numerical problem. Okay. Again, I repeat, XGBoost is not important from exam point of view. It will not be asked.
Okay. So here everything is on residuals.
Yeah. So let's solve our problem, right?
So basically it is a general framework, right? Like whenever you do a additive model, like that time you need to work on that residuals only.
Yeah, so see, basically XGBoost was something which this man was working on during his PhD project. So he found and came into all those formula, and which is now very popular and very widely used. Similar to this is there is something called L2 boost, but that did not
What boost?
L2.
L2 boost.
Yes.
Okay.
So XGBoost is very popular. You should go through the paper and all. Okay. So let's come to solving a question on this. Okay. So let's not take this example. Let's take some other example. Okay. So suppose I have some criteria x1 and there I have some y. Let me call 6, 8, 10. And let us call 14, 17, 21. Okay, I am taking only one feature and one target variable just to make you understand the steps. So what is step 1? In step 1 we find y hat.
Mean.
Yeah. So let us make it divisible by 3. Okay. So 14 plus 10 is minus 24. 7, 31. 31 plus 20. 52. So let's make it 20. So it will be 51. 51 by 3. Which is how much?
17.
1, 17. Okay. So y hat is 17. Next, step 2. So what will happen? Again, here our table will be formed x1, y hat. So 6, 8, 10, then 14, 17, 20, and y hat will be how much? 17 all, right? Okay, so step 2 is finding the residuals. So residual 1, R1 will be nothing but y1 minus y hat, which is
Minus.
14 minus 17 minus 3. Second will be 0 and third will be 3. Why we get numbers like this? We choose data like that, right? Last time we got minus 202. This time we are getting minus 303. So
Yeah,
minus
very
3.
well sampled data, and we are taking the mean.
Yeah. So minus 303. Next step 3. What we have to do in step 3? Anyone remembers?
That similarity measure we need to find out.
Yeah. So I think before that we have to do a splitting, right? Or okay, we can calculate similarity measure first. So let's call similarity, overall similarity. This will be equal to, yeah.
Similarity of what?
Similarity of data sets, you can say. I mean between themselves.
Like similarity of this data with this R residual.
No, similarity of this data with themselves. I mean this x 6 and 8 and 10 within themselves.
Okay.
You can consider like that, but it is more than that.
Okay.
So similarity score will be what? Sum of residuals, square it, then divided by number of residuals plus
lambda.
Okay.
It is 0.
So here, yeah. So here similarity score will be how much sum of residuals. So what we are getting minus 3 plus 0 plus 3, which is like 0 square. How many number of residuals? 3. And lambda, let's consider for convenience.
0.1.
We can take it 0, right?
Hmm.
If we take 0, it means we are not trying to reduce overfitting. If we take lambda equal to 1, it means we are trying to reduce overfitting to some extent. If we take 2, we are trying to reduce it further. Yeah. So let us call it 0 for convenience. So it can be 0, right? So similarity score that we got here is 0. Okay. Now next, let's choose a splitting criteria. Step 4 was choose a splitting criteria. So splitting criteria, suppose we take x greater than 6. Suppose we take this as splitting criteria. Then what should happen? Yes, no. So suppose I write yes here and no here. Then how many data points will be on this yes side?
2.
X greater than 6.
2.
Hello, am I audible?
Yes. Yeah, actually, like
2, right? So it will be corresponding to 8 and 10. So what we have to do now, we have to write residuals. So whatever model we are building is
So we are not able to hear.
no, actually you are audible with a very low probability.
I think he got dropped.
Disconnected.
So in one social group, they actually use the word that you are now gone to the matrix to describe this.
What is that? You are now?
Matrix, no, they make a call, right? There is this thing and they disappear, then they come back again. So they use the word that now you're in the matrix, now you're
Yeah, right, right.
Hey, sorry, I got disconnected. Am I audible?
Yeah, now you are very clear.
Yes.
Please repeat the last minute.
Yeah, sorry. So what I was, I'll explain it when I share my screen. So I'm not able to. Give me a minute.
Probably from step 3, like again you can start actually. Like we understood that similarity calculation.
Yeah. Okay. So I'll cover that part. Give me a minute. I am not able to share my screen.
No problem.
Here the split is based on anything, right? They're just making a random split.
No, see what happens, this split, we are taking anything, but what happens when we program it, the best split is taken. So for whom the Gini entropy is, Gini loss is minimum or the entropy is minimum? Okay, so I'm still not able to share my screen. So anything that you want to discuss till then?
Yeah, probably like this is a nice thing. Like probably like later on you can like record this video of your own and probably put it in the supplementary content
For XGBoost?
for
Yeah, or as a
XGBoost.
tutorial, right?
Yeah,
Yeah,
okay. So we may take this as a tutorial only or live session, or I will record it properly.
Yeah.
yeah, properly record it, because like so many times like your voice was breaking.
Yeah, okay. So I don't know where from today I'm getting a lot of bad network.
No, it is quite possible actually, because these entire 2 years the service providers were supporting us, right?
Yeah.
And now they are also fed up. Like, okay, go back to home, go back to work, man.
You know, okay, so now the similarity score, right? Now I have two
Yeah.
nodes, right? So each node has a similarity score.
Yeah, so
how
I'm
do I-
able to yeah. Okay, I'll explain. From step 3, you want to explanation?
From next page.
Okay. So see, what happens now, we have two results. So Srinivasan sir, what was your doubt here?
No. How do we combine the similarity score? So that was basically, I'll wait for you to finish the step, then I will ask the question.
Yeah, okay. So what happens now? We have basically two branches, and here we have what we did. We took the residuals on each, right, corresponding to this decision criteria. Next thing is, now let me call it some 1, and let me call it 2. So similarity score for 1. Similarity score for 1 will be calculated again by the same formula, which is sum of residual, then square it, then let me call number of residuals n plus lambda. Okay, and similarly ss2 we will calculate. So similarity score 1, what it will be? It will be 0 plus 3 square. How many are there now? 2, right? So it will be 2 plus 0, which is equal to 9 by 2, which is 4.5. Similarly, SS2 will be of what?
Same.
Minus 3 square,
okay.
1 plus 0,
yeah, 9.
which is 9. Okay, so this is what we are getting as step 4. Next, step 5. At step 5, we calculate the gain. So gain will be how much? SS1 plus SS2 minus SS0. So this is like after split.
So
and
this
this
was
is
my question. So we don't apply any weight.
What?
We just sum up the SS, right? You
Yeah,
don't
we sum up.
apply
We take the
any
sum.
weight on it.
Yeah, correct. So basically what we do, 4.5 plus 9 and minus 0, which is 13.5. Okay. Next step is step 6, which is like, so this is actually step 0. So we have a gamma in mind. So what this gamma is, basically gain. So this is like intended gain. We want our model to have as much high gain as possible. Okay. So suppose I consider I wanted my gamma to be 10. So what I am getting, 13.5. So if 13.5, which is greater than 10, then this split is allowed. And if this was not the case, then split would not have been allowed. Okay, so suppose I chose gamma to be 15, then 13.5 is less than 15, then split is not allowed. Got it?
Sure.
Yeah, okay. So this is the algorithmic part of XGBoost. Overall, so up to step 6, I think we are clear. Step 7 is nothing but finding the new prediction. So I may have written the numbers, step number may be different from what I showed you, but this is what happens, right? So step 7, what we do? We take new prediction. So new prediction is nothing but old prediction into eta into output. Sorry, not into, this is plus output. So old prediction, suppose for first I am taking for this 6. So for 6, the old prediction was 17. Okay. 17 plus eta 0.1 into output. Output will be nothing but sum of residuals divided by n plus lambda. So here the sum of residuals is 0. So it will be, output will be 0 divided by 3, which is, sorry, 0. Yeah, okay. 0.1 into this. So it will be 17 again. Similarly for y2, I'll get 17 plus 0.1 into, okay, not 0. Okay. Actually, this step I made a mistake here. It should not be, output should not be taken from here. What we need to see, so 6. So 6 is in which branch? Yes or no? It is in no branch, right? Hello, am I audible?
Yeah, I understand.
Yeah.
Okay, yeah.
Yeah. So what you have to do? You have to do 0.1 into minus 3 divided by 1. So it was in no branch. So for that we have to take output. So output here will be what? Sum of residual in no branch. So in no branch, sum of residual was minus 3, and how many number? 1. So it will be minus 3. So it will be 0.1 into minus 3. So which is 17 minus 0.3, which is 16.7. Okay. So similarly for y2, 17 plus 0.1. Now here the output was how much?
3 by 2. 0 plus 3.
Yeah, 3 by 2, 1.5, correct?
Yeah.
So which is like 17.15. Okay, similarly for y3. And now we will repeat.
Now we are
this step.
classifying. Okay.
What?
Now we are creating further split between the yes and no columns.
Yeah, correct. So now we can go ahead with solving this iteration by iteration, and we will be reaching at good accuracy. This is what happens in XGBoost. Okay. Okay, so I think we should quickly see an example from AdaBoost, right? Since we have very less time. So one more thing that I want you, encourage all of you to see is there are similar steps in XGBoost classification. The only difference is this formula for similarity score changes and new prediction changes. So I think if you have got the slides, so in slides they are there at the appendix side.
These XGBoost slides are there, you are saying?
Yeah, so in slides, I think this is at the appendix side, if you can confirm. So
XGBoost slides are not there in slides. It stops with the AdaBoost.
No, at the end in appendix, is it there?
No, I'm just seeing the slides. It's not there.
Okay, fine. So okay, so I'll share this tutorial at least with you. Okay. So this so exam point of view, this is not important. I am again mentioning, don't worry about it from exam point of view. Okay, so next step is AdaBoost, the last technique that we are going to cover here. So in AdaBoost, what happens? Okay, can you tell me what is the difference between AdaBoost and GradBoost?
In AdaBoost, we use decision stumps.
Okay, so stumps are nothing but only one root and 2 nodes, right?
Yeah.
Yeah, and we give more weightage to the like a misclassified point.
So the basic difference I have not yet got. What is the difference in the approach?
So it is a sequential model.
Yeah, you take different, you give changing the weights for the different samples.
Yeah, so basically, see, in boosting, whatever boosting you consider, we change weights. It's common to all boosting. But what happens in case of AdaBoost? The weight change is based on misclassified data. And in case of gradient boost, we have it is based on loss function. Therefore, the name grade boost, gradient descent. Okay. So this is what happens. This is what is the main difference. In AdaBoost, the weight is based on misclassified data, and in GradBoost, it is based on loss function. Okay. So what happens in case of AdaBoost? Let us consider there is a case where we have suppose two features, x1 and x2, which is having value 2, 3, 4, 5, and some 8, and maybe 9. Okay. So what I have done again, 2, 3, 4, 5, 8, 9. Okay. Now y, we have 1, 0, 1. Here we have 11, 17, and here let us say it is again 1. Okay, this is a kind of classification problem that we want to solve. Okay, so in AdaBoost, what happens? First step 1 is little different. What we do here, we actually take, we assume a weight. We call it weight. And this weight is calculated by 1 by n, where n is number of samples. Okay, so here what will be W weight? It will be 1 upon 4, right?
Yeah.
There are 4 records. So it will be 0.25. So we will assign weights 0.25 to all the records. So our initial assumption is all the records are equally important. Okay, got it?
Yes.
Yeah, okay. So next step. Step 2, what happens? Now we will see, we will take some stump. Okay, so how will we take stump? So a stump will be based on some, the decision on x1. So there will be a stump based on x1. Then there will be a stump based on x2. So basically a stump is nothing but a tree with 1 root and 2 nodes. That's it. So since we have 2 features, we will have stump 1 and stump 2. 2 stumps based on each feature. Okay. So now see, this stumps are selected based on this Guinea, or what do you call Guinea or Gini?
Guinea.
Okay. Next is entropy. So based on these two, we select the best stump. Okay. Next thing, step 3, what happens? We are in step 1, what we did, we assigned weights, equal weights to everything, because initially we assume every this record is equally important. Next, step 2, we created the stump. Now, with respect to stump, what will happen? Now there will be some misclassification, right? Misclassification based on stump. So suppose here this was the optimal stump. Okay, this was the best stump. So what we will do? So we will take stump 1. So in stump 1, suppose there are 4 records here. Okay, so out of 4, suppose 1 record is misclassified. So what is the error of this stump? 1 out of 4, right?
Correct. 1.
Yeah, so which is equal to 0.25. Now, next step will be, we were at step 3. So now, step 4, is calculating performance of stump. So performance of stump is nothing but half log E 1 minus error divided by error. Okay, so which is like here what we got? Half log E, and what is 1 minus epsilon? So epsilon
0.75
is
by
0.2.
0.2.
Yeah, correct. So it will be 0.75 by 0.25.
25. 1.2.
So which is half log E and 3, right?
3. Yeah.
So its value is I'm getting 0.549. So let me call it 0.55. Okay.
Yeah,
Yeah.
one thing, these log E and 1 minus epsilon by epsilon, this is the performance of the stump for
Which we
classification.
chose. Yeah, which we chose.
Now, say for example, what will be the equivalence in regression?
Again, in regression, we have to choose a threshold based on which we will decide which is the best term, right? So suppose the deviation between actual value. So suppose my data was like this, where I was getting y according to the actual y's was something like this, 10, 20, 30. So you have to basically do DT regression, right? So you know that, right? How to do DT regression?
No, that is okay. My point here is like
Yeah. So
step
see,
4.
and I am getting y stump. So y stump will be nothing but based on DT regression. Correct. So it will be having some value.
Right. So that will be the average of that particular region. Okay, and then like you can subtract those.
Yeah, and you can subtract those, and if the subtraction is in your range, then you will consider it as classified, or you will consider it as misclassified based on that error.
Correct, but the now the point here is like step 4. This log E log 1 minus epsilon by epsilon. This expression is for classification, right?
Yes.
Now, what will be the equivalent expression for regression?
So I think it will be similar. I mean, epsilon here error. So see again, what will happen here? The difference is 10. So I'm not very sure about it. I'll go through it, but for now, consider this. So
Okay.
suppose here it is 10, here it is 8, here it is 10. Suppose the threshold that you are choosing for right classification is 8. So you can tolerate a difference of 8. Then you will call it 1. You will call these two 0, 0.
Mm-hmm.
So
Okay.
epsilon here becomes what? 2 by 3.
Hmm.
So 2 were misclassified out of 3.
So this error actually like the one that you calculated, right?
Yeah.
Like I'm sure this is for classification, because you know like that corresponding like from where it is coming, basically the classification, like classification error,
Yeah.
from there this expression comes. This doesn't come from
Okay,
a
so its regression equivalent, I'll go through
yeah.
the
Okay.
material and then I'll come to it. Okay.
Okay, perfect.
And maybe I'll tell you in the next live session which we will have in week
Sure.
11.
Okay.
Okay. So for now, this performance of stump is like this. So okay. So next step 5. What will happen? We have to update weights now. So initially what we assumed, every weight is equally important. So now what we have to do, we have two things. Now for misclassified case, what we will do? We will take the weight, initial weight, and multiply it E raised to stump performance. Okay. And for classified case, which was correctly classified, what we will do? We'll do weight into E raised to minus stump performance. So by this way, we will get the updated weight. Got it?
So
So
here
basically,
one
yeah.
question, like say for example, if you do not give some kind of, say for example, the stump that that is predicting, that is misclassifying, okay,
Okay.
and that is a bad stump, okay, that is a bad stump, it is misclassifying. So based on his judgment, you will go and change the weight of the misclassified points.
So see, there will be several stumps based on the number of features, right? So out of all the stumps, we choose the best stump. And in that best stump, we see which is, what is misclassified and what is not classified. And after that, we find this epsilon. So suppose there were two stumps here, right? Based on one was based on x1 and other was based on x2. So in x1, what happened? In x1, there was only one case which was misclassified. X2 can have 2 or 3 misclassified cases. Therefore, we reject X2 then and there.
Okay. So
Got it?
is it the modified one or the like original paper is like that?
So originally is like that.
Because because I was doing studying on that, I thought like the original paper is telling like, okay, give different weightage to different classifier. Like if it is a very good like a bad classifier, if it tells that okay this is misclassified, do not update. But if it is a good classifier telling this point is misclassified, then you go ahead and update.
So maybe something like that would have happened
Because that
in the
is the
original.
reason they are taking another parameter called alpha into that e to the power alpha into stump performance.
Yeah, so if you have read the original paper, then there are a lot of things which changes on original paper. There are a lot of work. So finally, the AdaBoost technique that we see or which we use right now is this.
Okay.
Okay. Basically, if you see these steps, what you see for misclassified, what happened? Our weight has increased to 0.433 from initial 0.25. And for correctly classified, it has become 0.144. Now what will happen? Again, the whole thing will be repeated. The iterations will come, and this process continues till we reach up to a level where we are satisfied with the error that we are getting. Okay. So this is what all about AdaBoost. So we have covered, I think, GradBoost, AdaBoost, and XGBoost. So XGBoost is not in syllabus, so don't worry about it from exam point of view. I encourage all of you to go through it. And this regression equivalent of this performance of stump, I'll come if I come across, I'll surely let you know, like in next live session.
Yeah, in the discourse, there is a thread there we are writing one regression function for that. Probably you can contribute, you can post those things there as well.
Okay, sure. I'll go through it. So I think any doubt? I am done here with solve with us. I did not came with questions knowingly because I knew this explanation is required and it will take time because mathematical aspect of the things were not covered in lectures to a great extent.
Correct. So by any chance, this AdaBoost, does it improve the maximize the margin?
Margin, by margin, what do you mean?
Margin in the sense if I compare with a SVM, right? What SVM does is try to maximize the margin, right?
Yeah. Okay.
With AdaBoost, finally, eventually, you will be learning some kind of a decision boundary. Will it be maximizing the margin?
No, so there is no evidence as such.
No evidence as such.
Yeah.
Okay. Because I was thinking to take some points and try to see if that also happens, because this AdaBoost it is also going to reduce the variance, right?
AdaBoost is also going to reduce variance. Yes.
Because anyway you are learning sequentially and gradually you are improving upon that, right?
Yeah.
So from that perspective, since it is going to reduce the variance, So probably like that means say for example, if you are not maximizing the margin, then a slight perturbation might like lead a misclassification, right? So from
Yeah,
there
so
like
see, in SVM the process is altogether different. So there we learn a decision boundary, then we have two support vectors, and we increase that margin, right? So I think in no other technique anything like that happens.
no, see, like if you see that SVM, like first of all, like why we need to maximize the margin? Because like it will provide you a stable classifier, because
Yeah,
if
yeah.
there is
So
a
we
small,
want best decision boundary.
right, base decision boundary, so a slight perturbation in the data points will not lead you misclassification, right?
Yeah, correct, correct.
So it will reduce the bias towards one class and not other class. So that way, if I see even AdaBoost looks like it will also kind of do something, because it is taking care of those misclassified points and learning something good about it.
Yeah, so but here the approach is totally different.
Yeah,
Here the approach.
approach is different. That is perfectly all right. But
So
at
so
the
here
end,
we are learning no decision boundary, right? In support vectors, what happens? We really learn the support vectors and then a decision boundary. Here we are learning nothing like that. We are here only dealing with weights.
no, you are dealing with weights. But finally, say for example, your AdaBoost. Okay, finally, like when you give a test data, your AdaBoost will predict something, right?
Yeah, correct.
So you can always create a grid of xy, like x1 x2, and give it to him and see like how it is predicting.
Yeah, yeah,
That
correct.
way we
So
can come up with a decision boundary.
yeah, so I have not gone through that part for sure. So I will also try what happens exactly.
Okay, anyway,
So
like I'm planning to try it today. Like if I find some interesting like things, I'll put it in the discourse.
yeah, sure, sure. So that will help everyone. Okay, yeah, if you people want to solve something, I can give as a question. Otherwise, we can close the session. So I think this was
This was
a
helpful actually.
helpful session, right?
This session, yes, this session was like pretty much helpful instead of solving those like very similar questions, whatever is there in the video, right?
Okay, so again, I'm repeating: don't expect XGBoost in exams. This is important in terms of your knowledge. It is widely used, so you can go through it. But XGBoost is not going to come anywhere.
Okay, another
Bradboost
thing,
and AdaBoost. Yeah.
yeah, like so far, whatever we have been learning, right? That is mostly on like cross-sectional data, right? Like, is there anything that we are going to learn on a temporal data?
So see, I think in MLP you are dealing with a lot of data of different kinds.
Hmm?
So in MLP you are dealing with different kinds of data, right? Time series data and all.
No. Where time series data?
Okay, so I'm not sure we are going to do anything like that. So if it happens, it will happen in MLP, not in MLT.
Okay, in MLP it is like if it happens, okay.
Yeah, so in MLT we are more concerned with the basic part of it, right?
Yeah,
We are
that is correct. Yeah, that is correct. So, do you have any clue like what is there for like last 2 weeks, like 11, 12? For
so there will be clustering.
mhm.
Clustering will be there, and I think there will be neural network.
Okay, and like by the end of this, like, will you be giving us some pointers that from this point, like, what will be the like next things like that we need to like kind of
Sure,
like
sure, sure.
go
For
through?
that, we are always there. I mean, if you ask us something on Discourse, so this time we were a little bit less active due to many constraints, but for sure we will be helping you out whenever we get time. If you ask something, or even if we get something interesting, we will surely post on Discourse.
Yeah,
So
because
from
I was going through these some of the topics like auto regressor, auto encoders, but not sure like where exactly they will fit. Like after this, it will fit. Those things will fit, or like it doesn't fit like that.
So see, Rajiv, what happens in MLT and in MLP, we are giving you a very basic or a foundation of ML. ML has no boundaries. So it is used differently in different ways. So in business intelligence, it is going to be used differently. In case of text mining, it is going to be used differently. In deep learning, so there are so many things which is happening in ML. So this is, you can take it as a foundation, a primary course in ML. It's not like it has covered everything. Okay.
So probably in the last week, if you can include one slide like demystifying these facts, right? Like okay, you have done up to this much. These are the things like which
Okay,
is
so
in.
if you can come up with the field in which you want to work with, so even we can do that. I mean, if we, for instance, we take the banking field. So in banking field, what are the different ML things which is happening?
Okay.
In sports, what is happening? In, so see, it depends on field in which you are there. So,
Okay.
for
Okay.
instance, in case of fraud detection, only classification will be used. So, in case of something else, for business intelligence, they are going to do it. Again, depends on the business which you are taking into consideration. For instance, a automobile business will be taking into account all the things which is happening in oil. So, they will be taking everything related to oil, all the data which is happening, which has happened over the years. So, and now a social media site, it will see what is the general behavior of people when they sign in or sign up. So it totally depends on context. So there is something called topic modeling which happens. There is sentiment analysis which happens. Then a lot of thing happens which is beyond the scope of this course.
Okay, so probably what I will try, I'll try to put up some questions and probably some keywords, and then at least you can guide like okay, these are not relevant, or these probably can be studied. Okay.
Yeah, so one thing that I want to assure you, Rajiv, at least, that if you now go to any field of ML, these
Mm-hmm.
things are going to be used.
Yeah,
Whatever you have
these are
studied
the
in
building
MLT and
blocks.
MLP.
These are
Yeah,
the building blocks. That is for sure.
yeah.
Okay.
So we have only given you the building blocks, not the building. Building you have to build on your own.
Right,
So
right,
we
right.
can help you
Understood.
on that.
Yeah, yeah. Understood.
So I think if we are having no other doubts from anyone, we can close the session, right?
Yeah,
Yes,
sir, this
and
is not a doubt. I
Yeah,
just
yeah.
had one request. I've posted some doubts on SVM. So if I think whoever can address those, it'll be great.
Yeah. So I think Amrita ma'am will address those. So I'll
Sure,
tell
sure.
her.
Okay. Sure. Thank you.
Yeah,
yeah,
okay.
and in the next open session, probably can we take that SVM once again, because that will be anyway there in the exam, and SVM also quite a lot of
Yeah, so I think
confusions
there will
actually.
be a revision session for sure
Yeah,
before
the
the exam.
problem is this kind of session will be helpful, but say for example, if you are reading some slides, that will not be helpful.
Yeah, okay. So surely I'll inform our teammates about this. So what exactly you want, some kind of solving? Yeah.
Yeah, because that SVM was it was pretty much confusing for me at least.
It is. See, it's like Rajiv. SVM is one of the most debated topics in ML. It's not only with you.
Yeah, but at least I'm sure the confusions that I have can be solved, because in industry there are like a lot of intelligent people, they can go for that debate, not me.
You can go for the debate. You are intelligent enough. So yeah, it's nice actually. With these discussions, we learn a lot, right? So these
Yeah.
discussions are important. I'll
Correct.
for sure tell our team members to come up with something which solves your doubts,
Yeah,
and they should
actually,
try it.
one small, even open session, if like for SVM, if we can have, then that'll also be great. Maybe a 1 hour instead of 2 hour.
Absolutely, absolutely. That is a
Yeah,
great thing.
okay. So, okay, sure. So I'll convey this message to our teammates. So I'm not someone who is very good at SVM. Let me be frank. So I'll tell someone from our team who is very good at SVM to come up. Okay.
Sure. Thank you so much.
Okay, thank you so much. Yes.
Yeah. Thank you. Thanks a lot,
Yeah, have a nice
all of you,
weekend.
for participation. Yeah, same to you.
Not a-
Bye all.
Bye.